Hi everyone. Today I will take you through my proposal, or my thesis proposal, which is the first draft for today. So I hope you enjoy it. I hope if you have any question or comment, please you can stop me and you can ask me at the end of the presentation. So the beginning, we'll start with my what is blockchain, as we all know, but for other professors maybe they will not know. So I will just take summary for them. So it's distributed database, decentralized, and it's record which the ledger which lists all of the records of transactions from the beginning, from the Genesis block until now. So we also know that the blockchain is tamper-proof, which is proof of work, proof of stake, and other consequences, as you know, and public, as an example of Bitcoin and other also Ethereum and Litecoin cryptocurrency, and EFT hash, which is the block used in the hashing connecting to the transaction from the Genesis block until the meantime. So how blockchain works? It's basically a list of records, and if each block there is time step and link to the previous block by using the hash, and can we manage it by public or peer-to-peer or distributed stamping, and also the private based in that blockchain from the other like Bitcoin and Ethereum and the most known cryptocurrency we know. So the uses of blockchains. There is a bunch of uses: recording events, medical records, and other stuffs, as you know, all of that. But for my paper and my proposal will be like focusing on the digital payment or digital currency. So payment will be the most thing. But just that doesn't matter for the presentation. History of blockchain. Blockchain didn't start like 2008. Actually, it started before that. Time step was invented in 1991 by a paper by Stuart Haber and Scott Stondon, and then Dr. Anderson also write a paper about the record with the medical system, and then Michel Dolly and also they talk about the cryptocurrency before Nick Szabo was starting his paper, the BitGold, and then the Bitcoin in 2014, the blockchain to start. So this is, and to hear it's like summary for blockchain and how we can use it and how it's work and other stuff you see. From this slide, we talk about the problems. So the big problem with blockchain, there is like this is from my opinion. There is other opinions, there are other problems. Some of them they're like 5, 6, 7, some of them just 2. So in this slide will be like Bitcoin's scalability problem, which is the most, I think in my opinion, this big problem. And then the environment cost, which means the energy wasted and the expensive of transaction, for example, Bitcoin and Ethereum. And blockchain is a network that relies on nodes, and this is the most important for for today's presentation and my paper, because as we talked about last week and 2 weeks ago also, we mentioned a lot about nodes and what nodes it's important in blockchain, and they have big role in blockchain and so forth. And not completely secure as examples of other cryptocurrencies with the side chain and other cryptocurrency that use centralization system rather than public or decentralized system. So software-defined network. It's new technology in network. Actually, now it's implemented by, I think, 3 or 4 or 5 big companies. And the thing with the software-defined network, it's more distributed. So that means there is no one control, there is no one hardware. As before, we used to use one hardware software, and there inside that hardware we implement the network by using Windows network or with other network. In this software-defined network will be the hardware and the software, 2 different things. And that is you can run in Surface controller and also different node. And you see here the forward elements and then the control. So there will be data giving and taking, and there will be control data on that hardware of software-defined network. So this is yeah, and this presentation will be talking about software-defined network in blockchain, which is how to take the advantage and the most important things in software-defined network, and then application blockchain, and then like connect it together or try to implement one system or one technology in one good way, that will help us to solve our big problems, which I mentioned in the slide. So this is the architecture of software-defined network, as you say here. Application layer, which is business application layer. For example, for our example will be, let's say, like cryptocurrency payment machine or B2B like machine or other application. And then we'll see the control layer, which is software-defined network, and the infrastructure layer, which is the network device. And here, which I mean by network device, which will be node. So 1, 2, 3, 4, 5, and another number of nodes. So as you see here, the control data plan interface by using open flow data like packet transaction. So we send and receive from the network surface to the infrastructure layer, and you see there is one layer, another layer, and then the third layer. In the previous network system, like the old style one, it was one system. So there's one hardware, one software. Inside one hardware, you can control all networks. But here you see different and separate things, so that's make the software-defined network more secureable and more offensive in state of matter of like energy and cost and other things. This slide here more explanation about software-defined network that's work in API with different. So you see here, like from network, there will be control data, like open standard application provider interface. So there will be open like the application inside the nodes, all the nodes. And here, control platform, which will control logically centralization control. But when you go inside, it will be distributed. So there will be no one single point of system. So that's make it more secure, not like the old style network. Here, the protocol implications, as you see in this slide, how it's controlled platform and then control the application at the same time, which is not, which we couldn't do it before until software-defined network to come to this, to our system or to our network technologies. And here there will be summary of the software-defined network control. We see data plan and control plan, network device, which is the nodes in our system, and will be the open flow will control the data and control the plan between the nodes and between the software-defined control. So in this picture, there is one device, but in actually in real life, it will be 5, 4, 6 different devices, and there is every device connect to other nodes, and other devices also connect to other nodes, and so on and so forth. So we talk about blockchain and software-defined network, and the most important thing for us is the node, which is our implementation and our idea and our system will be working with nodes directly all the way from the beginning to the end, especially simplified payment verification, SPV. So this is from last time. We talked about the type of nodes and the healthy node, malicious nodes, and what difference between them, and so also the simple payment verification, the hash block hash header, how it's working from the transaction side, and by the child going the balance, and then the child also going the balance until the micro float, which is the block header. So there's no need to store all the blockchain transaction or header in one system. That will make it for not heavy and easy to use, especially in scalable, scalable system. And we talk also the path size. So from transaction 1 to point to the road node, how much time, like how much the size we need to do that. And you see here, when it's talk about more than 10 millions, will be 24 hashes. So this is a really good number to make sure that blockchain, this transaction, it's pointing in the blockchain and it's validate at the blockchain by using the more secure and more not heavy or something like the simple payment verification node. Yes, this is it. From this slide, we start our approach. So we have different architecture here. You see here the Central Verification Authority, which is the old system, which would not all, because nowadays they are working on it, but I mean, this is the one single point Central Verification Authority, which is when something wrong go with the Central Verification Authority, which this device or the servers, you cannot work in another. But here in distributed ledger, you see there's node, and there will be software-defined network control the node, so will be other, not only one centralized verification authority, so there will be no one device. And here another picture, you see the block, how it's the node here working with the consensus. In our approach will be simple SPV will be connect with the consensus in the blockchain and then connect to the public blockchain or for example Bitcoin or Ethereum. And here you see the nodes, here the nodes, and this one will be the software-defined network servers which control the data packet from sending and receiving from the P2P network and this application system. So to go more deep, how will be the blockchain working in this approach or this proposal will be, there is, as before in software-defined network, there is 3 layers, application and control, and then data layer. But here you see there will be blockchain, control the data layer interface, which will be software-defined network, and then application control layer interface, which will work with the business application. So you see here the blockchain will be nodes, as I said before in the previous slide. Will be node between node to node connection. So you see here our blockchain, and then the nodes and the controller will be software-defined network. And then mining nodes will be like, this was the first architecture I draw was by using Bitcoin, but I'm not sure if it's a good idea or not. And then also for basically the first thing will be blockchain, Bitcoin as far as I know. And this is the summary for also the same approach, location layer, control plan, and location layer, data plan as before we saw. So there will be access control from software-defined network, and then the blockchain will manage the data and the security about the transaction, which by pointing every transaction in the blockchain. And yeah, you see here that our experiment architecture will be, we need software-defined network, 3 or more for devices, and then we will use some Raspberry or some hardware device to manage the software-defined network, and then the router will be connected to blockchain rather than Ethereum or Bitcoin. And yeah, let's see how it's going, how it's work. So to summarize what I have been saying, software-defined network will offer new solution to long and standing network requirements. Of course, we're working with blockchain and will increase the deal with high cost and energy consumption. So there's be no like less cost and less energy wasting consumption. And software simple payment verification node will provide scale and lower hardware costs and the surface cost as well. Blockchain and software-defined network, the response to malicious attack will improve, as you know, because we have the controller system different from the node, so there will be the response will be more improved in this approach, blockchain and software-defined network. Yeah, and that's it.
I still don't get it, why we should be using the SDN.
In this nowadays network, there is one centralization applications server, so one device. And if you could hack, or if that device goes shut down or something happened to that device, you cannot connect the other nodes. in blockchain, there is like proof of work and proof of stake, and it makes it secure, okay, but not scalable. So that's why we need to use software-defined network that make distribution work very well without proof of work or without any consequence needed for more security. So this is the same like the idea, and basically, and you see here we have the blockchain. So we'll use the blockchain by using the SPV nodes, which is just pointing the transaction inside block. So if this transaction was already like 1 hour ago validated, yeah, it's correct. It's was 1 hour ago validated. So then will become inside the nodes, which will be, and there will be software-defined network system here, which control. So it's like a controlling one system to make it scalable and more secure and unhackable. Yeah.
So SDN server, is that helping for the systems?
Yeah. It's like taking out proof of stock or proof of work or stake, any consequence, and then using software-defined network.
Which tools it
It's centralized. Yeah. If we say it's here 100% centralization, here will be 40, 35, something like that. So yeah, there is will be, yeah, less centralized.
Could you re-explain the around and the last part of the presentation? 여기서 네네. 네. 네, 제가 받았어요. 네네네. 예. 예. 네네. 1시 30분. 네네, 알겠습니다. 한 4시쯤 끝날 예정인가요? 네. 근데 그게 이제 온라인으로 하면 온라인 참여자들도 질문하고 뭐 그렇게 되는 건가요? 예. 예. 네, 알겠습니다. 네.
Yes, Professor. So as you see in this figure here, software-defined network, it's more technology to control the data between nodes, especially in B2B network. So in blockchain, there is proof of work and consequence that make sure the security high is the security level is very high, and so on. But there is so many issues there. So in this approach, we will use the software-defined network to make sure the data and there is no malicious node inside our system. By working with blockchain, and when I say blockchain, I didn't mean like the Bitcoin or Ethereum. We'll use simple payment verification node, which is more right way to use blockchain in this approach with this system. So you see here, software-defined network will be like 6, 7, 8, any number of servers that using OpenFlow, which is the programmable code to manage the data between all nodes inside or outside the system, and then we'll send only the transactions to blockchain by using software payment, simple payment verification system. So this is the idea in simple. So you see we have 4 different layers. We just I use the application layer with the software-defined network layer, and then connect it to the LAN And then, yeah. So, yeah, this is the experiment. Experiment architecture, which is I already know now how to use a straightforward network and then switch between nodes. Also, will be this is a straightforward network control the nodes inside or the system, and then connected to blockchain by using the simple payment verification node. So it will be node, and then software-defined network, and then also simple payment verification nodes working in the system. If you will remember, I told in the slide, I said blockchain network is relying on nodes. So yeah, I work on this perspective. I focus on nodes and how can we manage to make a scalable approach for this system.
So, what are you proposing for your research? I still didn't get it.
So, will be this proposal. I just said, I think, to you. So, software-defined network with blockchain, and especially in blockchain, simple payment verification nodes. How can we make it work together to have one good and scalable, and there is no malicious nodes inside the system?
Then I guess what you need to do is then install, I don't know, buy that SDN controller.
Yes.
Then applying their network
Yes.
to the blockchain, for the blockchain communication.
Yes.
Then what kind of research are you going to do? So just buying it, and then is there anything you need to improve or you need to change?
Work like making this two systems working together, it's improved in itself. So inside chain or other chain, they work with the different centralization system. So different servers, but in that way, it's not secure. But when I use the software-defined network, it's more secure and more distributed technology.
Yeah.
So that makes it a bonus and plus for this approach.
So yeah, you're suggesting to use SDN.
Yep.
Then what kind of research you need to do to use SDN to blockchain? Do you need to change any part of the blockchain platform, or?
Yeah, we cannot use Bitcoin, which is the public blockchain. We'll use separate or different blockchain. So technically, will be private.
Okay,
blockchain.
okay, private is okay. Yeah. So it may.
This is the first idea of that system.
So
Maybe
yeah,
it will be improved.
So you assume you're gonna use hyperledger fabric.
Let's say, for example.
Let's say, for example. Okay, then we have a fabric, and we have a SDN controller. Then exactly, I think you need to identify exactly what research items, what kind of things you need to change or improve our research. I still didn't get it.
I like when you said fabric, you said you use software-defined network and with fabric. But the thing in fabric, there is no simple payment verification node.
Simple payment verification node.
So yeah, I am playing with the nodes here. I'm not playing with two systems. So software-defined network, it just control the nodes. I have 100 nodes right now, and these nodes, some of them they are malicious, some of them not working very well, some of them it's shutting down for like 2 weeks ago, and nobody knows. By using software-defined network, I will make sure that all system and all nodes work sufficient to make the system work right way.
Okay.
The right way, the correct amount of time, the correct amount of data, and this is we cannot do it in fabric example as the preferred process.
Yeah. So if we use SDN, then you can do very good management of network systems.
Not only software-defined network, I need to use also the simple payment verification nodes inside this system.
So you proposing using SPV?
Yes, sir.
No.
Yes. So this is the technical or the smart thing in this paper, as far as I know, is not just using two different system or technology. It's how to implement that simple payment verification nodes inside software-defined network node or controller, which will help all in the blockchain area to scalable and flexible.
So you're saying if you use SPV, if you add SPV node to the blockchain network,
Yeah.
then what's going to be benefit?
The problem now with the simple payment verification nodes, when if you see here, Professor, this picture, let's say the lights client, we're hitting the SPV nodes. In our systems, when we have 1,000 nodes in Bitcoin, for example, just 200 of them will work like client. The other nodes will work full node. So even by using simple payment verification nodes in our system, still we cannot do like more network or more nodes in our system. So by using software-defined network, let's make sure 200 of them is enough for our system to work, not like in Bitcoin when we have 1,000 nodes, for example, and just 200 of them will work with us.
Okay, you're saying we can reduce the number of nodes, even though we can make it very reliable.
Yes, and this will not happen without controller and without something can control the data between the nodes, whether for instance in Bitcoin or Ethereum, like proof of work and proof of stack, or in my approach here, software-defined network.
Okay. So what is the function of SPV node?
Function of SPV node is like
Same. What's the difference between the so full node has a full blocks.
exactly.
SPV only has headers then?
Yeah.
Headers.
Do you remember last 3 weeks ago, Professor, when I talk about the SPV? It's only
even Bitcoin network, yeah. Light node has only headers.
yeah. But
What's the difference?
there's problem with there's issue with security and scalability. Still,
Okay. So you're saying if we use SDN, then even only using SPV, that's going to be enough. We don't really need big number of full node.
no, in the beginning, yeah, we need just small number. But after 3 or 4 years, there will be the giga, like the amount of block headers will be 20, 30 gigabytes. We also need to increase our nodes. And the thing we are increasing nodes is not expensive, like blockchain and in traditional network. The server will be, let's say, $10,000. And our system here, the nodes will be more or less like acceptable.
Okay. Then do you need any research on this SPV node? Are you just using SPV node itself, or do you need to create any?
I need to change the code, of course. Obviously, I need to change the code, and also I need to see how it's implemented in the white paper by Bitcoin, because I try to find anything. It's mentioning in the white paper, but there's no real, like, I would say, using. So in blockchain white paper, they're full node. It's mentioned, and everyone working with it, and everyone know how to do it and how it's working. But here, they try to do it, but the problem, as I said before, the nodes is not enough. So full node will be something like this. The light nodes will be something like this. And inside this, the SPV nodes will be very little numbers.
Yeah. So okay, right now very little number of SPV users.
Yeah.
So now then you suggest that we can increase the SPVs?
If you increase the SPVs, it's not solving the problem. We need to have systems that control.
Yeah, so that's SDN, right?
Exactly.
So still, for me, so I want you to list what kind of research issues you have to implement SPV-based blockchain network. You're suggesting, yeah, we only need the SPV. That's gonna be enough. If we use SDN, okay, now let's say I agree that, then, okay, then first question is, okay, to use SDN, do we need any research? Or we just install the SDN, buy the SDN controller, install it, then is that gonna be enough?
No. SDN network, when it's work with blockchain, it's different system as before. So, for example, Professor, as you see here, software-defined network, it's different layer and different system. It's work with nodes, it's work with blockchain, it's work with traditional network.
So, yeah, to do that, then you only just draw the picture, but then do you change anything, or do you need to add any algorithms, or do you need to adding that kind of items? For me right now, it looks like, well, okay, we buy the SDN controller, install it, then we just create the many SPVs. Then what?
I think
then,
it's the picture. It's show you that it's very simple, but no, in real life it's not that simple.
Okay, so
I need to implement like the
because
I see before it's proposal, so I cannot give the result right now.
Now I understand that you are proposing stages, so you just imagine, okay, if we use SDN, then we can make a very light blockchain in compare with others. Okay, that's fine, but then maybe first thing you need to do is do it. Okay, try to install the SDN and then maybe create the SPV-based blockchain network, and then maybe you will figure it out. Many research issues.
Last time you said when we talked to you in your office, after the proposal, like to other professors, if they said okay, you said you can go, but before that, don't start anything to buy anything because it's expensive and you cannot do that. So, for example, if they said no, you have to change your proposal, you can, you have the time to do that.
But because you're just saying using the SDN, but still you didn't then list out the research items.
It's not.
We need to change or we need to do something. I didn't see it. That's what I'm saying. If you cannot really find out what kind of research issues exist in that proposal, then probably maybe you can try. Otherwise, you might not know what kind of things you need to do research. Or do you know what kind of research items you need to perform?
Yes, sir.
Can you list down?
Yes, sir.
List up? Where is it?
We start from the beginning and find the problem. When I said we work on nodes, so our
blockchain is that relies on node.
Yeah.
Okay.
So this is the point. So this point will be software-defined network, and this is all will be nodes. You see the other colors except the black and the gray one. And here the nodes we talked about before. By using software-defined network, how can we implement this system? Plus using the software.
Okay, so now you said, how can we implement the system?
Yeah.
Okay, that's a very big question.
Yeah.
But it's not a research issue. For me, it looks like it's not research. How can we implement the system? Is something like you need to learn the SDN, you need to read the manuals and then you install it. But then that's not research.
If the professor, like, if you remember the last papers, we talked about it last time, it's something similar to this approach. So blockchain, in other papers, they're using, for example, sidechain.
Okay.
And other papers also show that how we can use, for example, AI or machine learning to make a scalable blockchain or scalable system out of blockchain. So in the end of the day, it will be the same thing.
Okay. Yeah. You
So it's-
make
it's-
a very interesting point.
Yeah.
Okay. One guy said in one paper they said, how can we use AI in the blockchain, and then they created something.
Yes.
AI based.
Yes.
But however, there must be some issues, some specific items.
Yeah, of course. In the paper will be, as I mentioned in the paper, when use software-defined network with the simple payment verification node, there's so many issues will face us. One of the issues is the node numbers.
Node number.
Yeah. So in real life, we need more, like big amount of numbers. But by using software-defined network, that number we can decrease and we can control. So
That's
here,
the benefit. That's the benefit of using SDN in the blockchain.
yeah, by solving the problem, which is the problem in the Bitcoin before, we cannot use light client, which is software, which is simple payment verification node, because there's no so many nodes in our system.
So you're saying if we use SDN, then we can reduce the number of SPV nodes.
Yes.
Then actually, for me, it sounds like you don't really create anything. You just buy the control device and install it, then it's going to work.
No.
No?
No, sir.
Then what kind of things you... So I want you to the list itemize, okay, to do that, okay, to implement SDN on the blockchain, then what kind of things you need to do? That's maybe because I don't understand SDN deeply,
Okay.
but somehow I need some kind of research items. That's still, I'm not sure whether it is, it deserves a PhD research issue or not, because I haven't seen any list of research items yet, or a specific problem. Then, okay, to install the SDN, to implement the SDN, what's the current problem? Is there any problem exist?
Yes.
Yeah.
Any other comments?
Yeah. So I want you to kind of list down what kind of things you need to do.
Okay.
So, okay, sounds like idea is good. By using SDN, maybe we can create the network issues or number of node issues in blockchain. Sounds very attractive. But you mentioned someone else already,
Someone else in other systems, not only in this software-defined. Software-defined network, it's work with different technologies. It's not something for me or for like blockchain. The same thing. So when I mention this paper, mention software-defined network, it's not that bad. It's something good. It's new technology. So many people they are trying to implement. So this is the point from my idea.
So that's good technology. I mean, sounds like that's good technology.
Yes.
Then to introduce SDN to blockchain, then is there any problem? That's my question.
Yes.
You mentioned AI. Okay, AI, using the AI will be good. Then what area are we going to use? Say, we're going to use AI in consensus algorithms. Then more one step level specific, but to do that, then maybe you need to do more research. Okay, in consensus algorithms, what part of the consensus algorithm AI will contribute? So that kind of, something concrete, something, we can see. But
Okay.
now, right now, I think your idea is good, but somewhat you need to do. Yeah.
Because yeah, as I said before, it's proposal approach. So I don't want to go deep inside this presentation because I will present it in front of other professors today, just practicing.
Okay. Yeah.
So
Yes.
this is-
So
this
yeah,
is-
you need to improve, but
Yeah.
so I think either you just find out the specific research issues based on your just reading the papers or based on your own research.
Mhm.
That's one approach. If you really cannot extract specific issue unless you really do it, then maybe we need to do.
Okay.
Because it's just only imagination maybe has a limitation, right?
Yes, sir.
Unless you really do it.
Yes. So you mean do it and then after that?
So whatever, either way, but I mean, before
Because-
we invest, I don't know how much is it, the SDN?
It's not expensive. I will not use any expensive hardware. I will just use Raspberry.
So whatever, oh, then I mean, easily we can support. So anyhow, if you can identify specific research issues, then that's good. If you cannot identify it, then maybe you just do it first. Then probably you will come up with some specific questions,
I think-
specific issues. Yeah.
I think I can identify it. Next time I will do a little
So,
note
yeah.
in the presentation. Yeah.
Yeah, so I want you to be more specific.
Yes.
Now I accept. Okay, good. Yeah, maybe we can resolve current blockchain problems by using SDN. Sounds very attractive.
I understand.
Then what kind of things we need to do?
Yes, sir.
Okay. Good.
Okay.